In this video, I'm going to teach you how to very quickly predict the charge on ions. As a reminder, an ion is an atom that has either gained electrons or lost electrons, so the number of protons is no longer equal to the number of electrons. I'm going to be using electron configuration as a way of explaining how atoms ionize, become ions. And so I've got 4 atoms here with the electron configurations already all written out using noble gas abbreviation. And let's just really quickly look at the periodic table and find these 4 atoms so you kind of have a mental picture of where we're working. We are looking at sodium, magnesium, sulfur, and chlorine. These are just the ones that I picked to work with. So what we know about atoms when they're ionizing, we know that they will either gain or lose electrons so that their electron configuration matches identically to the configuration of the nearest noble gas. So that means for the sodium atom, it is either going to gain or lose electrons so that its electron configuration changes in such a way that it is identical to the nearest noble gas. So let's just start by finding the nearest noble gas for all 4 of these elements. Which is the nearest noble gas? I'm just going to abbreviate nearest noble gas. For all of these, we're looking for the nearest noble gas, and of course we're going to have to go back to the periodic table to check this out. Now you might be just saying, can't we just assume that neon is the nearest noble gas for all of these? And the answer is unfortunately no. The noble gas that we use for abbreviating electron configurations is the last noble gas, not necessarily the nearest noble gas. For sodium, it has an atomic number of 11. So when we're finding the nearest noble gas, we want to go over to the noble gases and we want to find the noble gas that has an atomic number closest to 11. And so for sodium, that is going to be neon, which is coincidentally the same one we're using for our abbreviation. For magnesium, atomic number 12, let's find the nearest noble gas. Again, that nearest noble gas is going to be neon with an atomic number of 10. So let's write those 2 down before we forget them. For sodium, the nearest noble gas is neon, and for magnesium, the same. Now let's take a look at sulfur and chlorine. Sulfur's atomic number is 16. Over here, which noble gas has an atomic number closest to 16? That's argon. And for chlorine with atomic number 17, also argon is the nearest noble gas. So for sulfur and for chlorine, our nearest noble gas is argon, not neon, so not the same one that we would use for abbreviation. So again, why are we looking for the nearest noble gas? We want to have our atoms gain or lose electrons so that their configuration matches that of the nearest noble gas. So let's go back to the periodic table again, and I'm going to unhighlight most of these because I want to just focus for now on sodium and its nearest noble gas, which is neon. So for the sodium atom, what would it need to do in terms of its electron configuration so that it would have the exact same electron configuration as neon? Well, the sodium, we know it has 11 protons, it has 11 electrons. It really only wants to have 10 electrons. It wants to back up the number of electrons so that it matches up with neon. So we know that for sodium, for the sodium atom, what it wants to do is lose 1 electron so that its electron configuration matches that of neon. And when it loses 1 electron, its charge is going to be a +1. We can make the same type of generalization for any element that is in this same column on the periodic table. All of these elements have the exact same electron configuration. All of these elements are just 1 block ahead of their nearest noble gas, every single one of them. And every single one of these elements is just simply going to want to lose 1 electron and form a +1 charge when they ionize. So that's pretty simple. Every single element in group 1A forms a +1 ion. Let's go back and let's take a look at our next atom, which is magnesium, and its nearest noble gas, which is neon. So back to the periodic table again, and let's focus again on magnesium. And what does magnesium need to do in order to match up with its nearest noble gas, which is neon? So magnesium, being in this position, number 12, trying to match up with that of number 10, needs to lose 2 of its electrons to back itself up to the configuration of neon. So let's write that down. We want magnesium wants to lose 2 electrons, and when it loses 2 of its negatively charged particles, it's going to end up with a charge of +2. I see that I used the number sign up here instead of the plus sign. So when magnesium ionizes, it loses 2 electrons, which results in having a +2 charge. And again, we can make that exact same trend for all of the elements that are in this column on the periodic table. Every single one of these elements is 2 blocks ahead of its nearest noble gas, and every single one of these elements is going to want to form the +2 ion. Let's take a look at example number 3. So for example number 3, we are looking at sulfur and its nearest noble gas, argon. Let's go back to our periodic table again, and let's change our highlighting. So we want to focus on sulfur, which is right here, trying to match up with argon, which is right here. So now we have kind of a different situation. We've got sulfur that's trying to resemble the electron configuration of argon. Sulfur is actually 2 blocks away, or 2 blocks behind that of argon. So sulfur needs to actually gain 2 electrons to get itself up to the configuration of argon. Let's write that down. Sulfur needs to gain 2 electrons, and when it gains 2 electrons, it's going to end up with a charge of -2, because now we have 2 extra negatively charged particles. Back to the periodic table, we can make the same type of generalization for all of the atoms in this column. All of the atoms in this column are 2 blocks away from their nearest noble gas, and so all of these atoms are going to form a -2 charged ion. Let's go back to our very last example. Our last example here is chlorine and its nearest noble gas, which is argon. Let's find those on the periodic table. Chlorine is right here. And so what does chlorine need to do to match up with argon? Chlorine is only 1 electron away from matching up with argon. When it adds that 1 electron, it's going to have a -1 charge. The same is true for fluorine, for bromine, for iodine. These are only 1 electron away from matching up with their noble gas. Let's make some notes about that. Chlorine will gain 1 electron. Gaining 1 electron means that it has a charge of -1. Let's go back to that periodic table one more time. There's a few areas on our periodic table that we haven't talked about. So first of all, what could we say about the atoms that are in this column right here? Where are they with regards to their noble gas, nearest noble gas? For all of these elements, so you see boron, atomic number 5, which is the closest noble gas. Looks like 2, 13, closest to 10. So these are elements that are all going to lose 3 electrons to match up with their nearest noble gas. They're all going to go back by 3 spaces. So all of these elements are going to form +3 ions. What about these guys right here? So these guys are moving ahead, adding, in this case, they're adding 3 electrons to match up with their nearest noble gas. So all of these are going to be -3s. What about for this block right here, this column? So let's focus on carbon. Carbon is 4 electrons away from 10. It's also 4 electrons away from 2. Whoa, what do we do in this situation? these guys right here actually don't form ions. Maybe because they don't know what to do. Should they gain? Should they lose? They don't know what to do. So this whole entire group 4, they're just not ionizing. What about for the noble gases? I mean, they're already perfect. They don't need to ionize either. So no ions there. These elements down here, these form unpredictable charges that we just kind of take on a case-by-case basis. So as a Gen Chem student, what I always encourage you to do is memorize sort of this mantra: +1, +2, +3, nothing, -3, -2, -1, nothing. And that will help you very quickly look at an atom and predict its charge.